Okay, today's lesson is in conic sections, and we're going to talk about circles. Okay, my objectives in this lesson are I can identify circles from graphs, standard form of the equation, and the general form. I can graph circles given the standard form of the equation or the general form. And I can find the standard equation of the circle and identify the center and the radius. So originally the Greeks discovered this from 600 to 300 BC, and they were mostly interested in the geometry of it. But this ended up being the foundation for the development of calculus that came afterwards. So what are conic sections, or simply conics? They are the intersection of two double-napped cones and a plane. So the four basic conic sections are formed when the plane does not pass through the vertex. So the vertex is right here. So when I do not pass through the vertex is when I have my four basic conic sections. So the first one is where the plane crosses my cone, I have a circle. When I'm at an angle like this, then I get an ellipse. When I'm in this portion of the cone, I get a parabola. And when I cover both cones, I have something called a hyperbola. So I'm thinking at this point you should have worked with circles, ellipses, and parabolas. And just the hyperbola should be new. Okay, in the case where the plane does pass through the vertex, we have what is called a degenerate conic. So when I pass through the vertex like this, I have a point. When I pass through like this, I have a single line. And when I pass through like this, I have intersecting lines. Okay. Okay, so let's get started. So let's review. This is from geometry. So by definition, as a circle is a set of all points in a plane that are equidistant from a given point called the center. The standard form for the equation of a circle is x minus h quantity squared plus y minus k quantity squared equals the radius squared. So this is from geometry. So the intro for pre-calculus is now, when I include all the conics, I have a general form. And this is the general form for conics. So for me to identify when I have a circle, I know that the coefficient A and the coefficient C are equal. Okay, so where does this x minus h and the y minus k come from? So let's just take our circle here, and if I break this down into a right triangle and bring these points down to our x and y axis. So this point here on my x-axis is the x coordinate h, and here the x coordinate is x. Here my y coordinate is k, and here my y coordinate is y. So anytime I want to find the distance, I subtract. So this distance right here is going to be x minus h. And this distance here is going to be y minus k. And the hypotenuse of this right triangle is r. So looking at the equation, I'm really just applying the Pythagorean theorem. The leg squared, which is x minus h, plus the other leg squared, which is y minus k, equals the hypotenuse squared, which is r squared. Okay, so let's start working with this. If I have a point, 1, 4 on a circle, and my center is at -2, -3, write the standard form of the equation of the circle. So I know h is -2 and k is -3, and they're telling me this. So I want to find the radius. So I'm going to just substitute into my equation. Here's my x and y. I'm going to say x minus h quantity squared plus y minus k quantity squared is my radius squared. So I know what x, h, y, and k are. So substituting in with the given information, I can solve for my radius squared. So x is 1, h is -2 quantity squared, y is 4, and k is -3 quantity squared. And minus a negative becomes a plus. So I'm adding, so 3 squared is 9. That's 4 plus 3 is 7. Squared is 49. Equals r squared. 9 plus 49 is 58 equals r squared. I don't need to know what r is because I'm substituting r squared into my equation. So just rewriting now, I have x minus -2 is x plus 2 quantity squared plus y minus -3, which is y plus 3 quantity squared, equals 58, my radius squared. Okay, let's try the next example. Find the equation of the circle with a radius 3 that has its center in the first quadrant and is tangent to the y-axis at 0, -2. So I know I'm in the first quadrant. Tangent means I touch the circle just once. So at 0, -2. So I'm going to touch the circle here. And then I'm going to just kind of sketch in my circle. So here, and then I have my radius of 3. So I'm going to draw on a radius of 3. So if my radius is 3, I know this is 3. So I know the center of my circle. My h value is 3. My k value is 2. So my center is at 3, 2. And the radius is 3. So now I can substitute into my equation. So I have x minus 3 quantity squared plus y minus k, which is 2 quantity squared, equals my radius squared. So 3 squared is 9. Okay, so this is geometry. So let's move into some more algebra 2 related information. Okay, when I want to convert from my general equation of a conic to standard form, I need to complete the square. So we learned how to complete the square in Algebra 2. So I know I have a circle looking at this because A is 1 and C is 1. So when A equals C, I know my conic section is a circle. So later, when we have worked through all 4 conic sections, we're going to have to identify what we have from the equation. So I need to complete the square. Okay, so to get it into the format I need, so I'm going to kind of write this in 2 sections, my x values and my y values. So I have x squared minus 6x plus, and I'm going to leave a blank. And then I'm going to do the same thing with my y values. So I have y squared minus 2y plus a blank. And then I am going to move 6 to the other side. So I'm going to subtract 6 from both sides. So there's a minus 6. And then for each of these 2 blanks, whatever I'm adding on the left, I'm going to also add on the right. Okay, so what I add to complete the square, I'm going to take half of my b value and square it. Okay, so my b value for my x coordinate is 6. So I want half of 6, which is 3, and square it. 3 squared is 9. So if I add 9 on the left side of my equation, I'm going to also add 9 on the right side. So same thing for my y coordinate. So 2 is my b value. So half of 2 is 1. 1 squared is 1. So if I add 1 on the left, I'm going to add 1 on the right. Okay, so when I'm rewriting this now, this gives me a double root. So this is going to be x minus 3, which is the half of the b value quantity squared, plus y minus 1 quantity squared, and negative 6 plus 9 is 3, plus 1 is 4. So my center, it's asking me to find the center and the radius. So my center is at 3, 1, and my radius is 2. Square root of 4 is 2. Okay, so just to review what was, if I wanted to show you what this, like completing the square looks like, this was working with those algebra tiles. So this would be x squared, and I had 6 x's. So if I started out with, I had x squared and 6 x's, what would I need to complete the square? So if I was filling these in, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I would need 9 of the constant to complete the square, to make this shape a square. So that's where this 9 is coming from. Do we remember this from Algebra 2? Because that was an Algebra 2 concept. All right, so let's add a few more things in here. Another equation, let's find for x and y intercepts. Find the x and y intercept of the graph of the circle given by this equation. So I know when I have an x-intercept, I know y is 0. and I know when I have a y-intercept, x equals 0. So something is 0. Okay, so substituting into my equation, I'm going to start out by substituting y is 0 and solving for x. Okay, so x minus 4 quantity squared plus 0 minus 2 quantity squared equals 16. So I have x minus 4 quantity squared plus negative 2 quantity squared is 4 equals 16. So I'm going to subtract 4 from both sides. So I have x minus 4 quantity squared equals 12. Next, I'm going to undo the squaring. So I'm going to take the square root. Whenever I take the square root of one side, I take the square root of the other side. So I want to simplify the square root of 12 with any perfect squares. So 4 is a perfect square. So I am left with x minus 4 equals 2 times the square root of 3. So I'm going to add 4 to both sides. So I get x equals 4 plus or minus, oh, this is plus or minus. So when I take the square root, it's the plus or minus. So 4 plus or minus 2 times the square root of 3. Now let's find the y-intercept. So I am going to set x equal to 0. So this is 0 minus 4 quantity squared plus y minus 2 quantity squared equals 16. Negative 4 quantity squared is 16 plus y minus 2 quantity squared equals 16. So I'm going to subtract 16 from both sides. So I get y minus 2 quantity squared equals 0. I need to undo the squaring. So I'm going to take the square root of both sides. So I get y minus 2 equals 0. So I'm going to add 2 to both sides and I get y equals 2. Okay, when graphing a circle, I need to plot the center and I have 4 additional points. The best way to remember that is I want north, south, east, and west. So I need a radius away in the horizontal and the vertical directions. So sketch the graph of this equation. So h is negative 4 and k is 1. So my center is at negative 4, 1. So negative 4, 1. And my radius is the square root of 9, which is 3. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So here is my circle. Got it. That's it.